All right. So, like I said, last 2 weeks or so, we look at weathering, and then we look at the definition of weathering, and then some other issues. This week, we're going to look at mass wasting. I think I told you last 2 weeks or so, when we ended the lesson on weathering, I told you we're going to look at mass wasting when we resume our lessons. All right, so today we'll look at mass wasting. Mass wasting. So let's look at the overview. Let's look at the overview, the lesson overview. Now, what are we expecting? What are the issues we are hoping to look at once we delve into this lesson? First of all, we shall look at the definition of mass wasting or mass movement. Then we'll look at factors that affect mass movement. Then we'll also look at types of mass movement. Then we'll see whether we can differentiate between mass movement and then erosion. And then finally, we shall also be looking at the effects of mass wasting. All right. What are our learning objectives? What are we hoping to achieve at the end of this lesson? First of all, you should be able to define mass wasting or mass movement. Then you should also be able to state and then explain some of the factors that affect mass wasting or mass movement. Thirdly, you should be able to explain the various types of mass wasting or mass movement. Then also, like I said, you should be able to differentiate between mass movement and then erosion. And then finally, you should be able to outline some effects of mass wasting. You should be able to outline some effects of mass wasting. All right. Now, having gone through the lesson overview and then our objectives for this lesson, let's look at the definition or the explanation of mass wasting. How can we define or explain mass wasting or mass movement? How do we explain or define mass wasting or mass movement? All right. So we refer to mass wasting or mass movement as a downslope movement, as the downslope movement of weathered materials, such as debris, loose gravel, clay, and mud, under the influence of gravity or under the influence of the force of gravity. I'll take that again. You can define mass wasting or mass movement as the downslope movement of weathered materials, such as debris, loose gravel, clay, mud, and other weathered materials under the influence of gravity. Now, there is one important point you need to note here. There is one important point you need to note here. Now, what are we saying? What is this important point that you need to note? We are saying that all mass wasting or mass movement occurs on slopes. All mass movement or mass wasting occurs on slope. And for that matter, sometimes we refer to mass movement or mass wasting as slope movement. I believe this is clear. All right. So this is just a brief explanation or definition of mass movement or mass wasting. All right. Now, let me be quick to add. We are saying it is the downslope movement. It is the downslope movement. That is why I indicated that you need to note that this movement or wasting occurs on slopes. Occurs on slopes. Who is that? What is happening on our screens? Who is doing that? Now, when rocks or other weatherable materials are broken or disintegrated, there is the possibility of this weathered materials being moved downslope from their location where they have been disintegrated to a different location. And this should happen on a slope. This should happen on a slope, not a flat environment, not a flat landscape or a flat environment. So take note. Now, what are some of the factors that are likely to influence or affect mass wasting? What are some of the factors that are likely or that can affect mass wasting or mass movement? So we shall look at a few factors that influences or that affects mass wasting. All right. In the course of the lesson, if those of you who are joining us or who are new here, if you are not clear with any of the explanations or you want me to re-emphasize a point, you are at liberty to do so. Just raise up your hand. I'll see you, and then I'll give you the opportunity to do so. If you want to ask questions, you can equally do so. All right. So let's look at the factors that influence or affect mass wasting. The first one we are talking about here is the gradient or the slope. The gradient or the slope. How can gradient or slope as a factor influence or affect mass movement? Now, take note, we define mass movement as the movement of weathered material, the movement of weathered material downslope under the influence of gravity. So how can the gradient or a slope of a particular landscape or area influence or affect mass wasting? Who can try? All right. So if I ask a question and then you have to you want to respond, raise up your hand and then you can unmute yourself so that I can hear you. Is that okay?
Okay.
Yes.
Okay, sir.
All right. So so let's continue. We are looking at the factors that influence or that affect mass wasting. So the first one we are looking at is the gradient or the slope. We are looking at the gradient or the slope. So I asked an earlier question whereby I asked you guys to explain or tell me how the gradient or the slope of a particular landscape or area can influence or determine the rate of mass wasting or mass movement. Now, all right. So what is the gradient or the slope? We are looking at how steep or how gentle the area is. We are looking at how steep or gentle the area is. So in areas where the slope is very, very steep, in areas or in locations whereby the slope or the slope of that particular landscape or area is very steep, then we are expecting to have a faster or a more frequent movement of materials. We are expecting to have a faster or a more frequent movement of materials in that particular landscape where the slope is very steep. Same applies in areas of high altitudes, areas of high altitudes. And basically what we are referring to is the mountainous areas or mountainous regions. In these regions, due to the slope of uh, the land or the landscape, there's a high probability of what movement of weathered materials in these regions compared to areas where the slope is relatively gentle. So take note, that is for the gradient. Once again, we are saying weathered materials tend to move faster in areas where the slope is very, very steep compared to areas where the slope is very gentle. So the steeper the slope, the faster the movement of the weathered materials. And then when the slope is more gentle, then we expecting this weathered materials to have a slow movement. So that is for the gradient. That is how the gradient can affect or influence the rate at which weathered materials are likely to move in a particular landscape or in a particular region. All right, let's move and then look at the second factor. Let's look at the second factor. We are talking about the human activities. Human activities. So human activities such as mining, construction, and other real estate activities. These activities have the potential to cause weathered materials to move at a faster rate. Now, why are we saying so? Why are we saying so? The activities of a man, particularly on mountains, on areas where there are highlands, activities of man such as farming, construction in these areas tends to allow these weathered materials to be able to move, down slope, to be able to move down slope. Now, do not forget that the main agent responsible for the movement of these weathered materials downslope, the main agent here is gravity, is the force of gravity. So once these materials become loose on a particular landscape, and then the force of gravity acts upon these weathered materials, then we are expecting them to move. And once they move, then we call this a process or this development mass wasting. Let's move ahead and look at the other factor, the presence of vegetation or vegetation cover. The presence of vegetation or vegetation cover. Now, in areas where there are thick vegetation, listen carefully. In areas where there are thick vegetation cover or we have thick vegetation, the thick vegetation tends to act as a protective factor or a protective mechanism, protecting the materials, the wet materials, from being transported or being moved downslope. Now, in areas where there are no vegetation or there are no thick vegetation cover, then the materials are further exposed because there are no protective mechanism, and for that matter, they can easily move downslope. So basically, this is what we are saying. This is basically what we are saying. We are expected to see more movement of weathered materials in thick vegetations, in thick forest. We are expecting to see weathered materials being impeded with regards to their movement. They are not likely to be moved at a faster rate when there is a thick vegetation cover compared to areas or regions where there are no vegetation cover at all. So basically, what are we saying here? The presence of vegetation or the vegetation cover tends to act as a protective mechanism, protecting the weathered materials from being moved or being carried downslope. That is when we have thick vegetation cover. In areas where there are no vegetation cover, then this weathered materials tends to what, to move at a faster rate just because there are no protective mechanism or no protective elements to help or to prevent these weathered materials from being transported or being moved downslope. So that is basically for the vegetation cover. All right, let's continue and look at the fourth factor. Here we are looking at the nature and the weight of the material. We are looking at the nature and weight of material being moved downslope. Being moved downslope. remember what I asked you to note in our definition, that all activities or all processes of mass movement occurs on a down slope, or it occurs down slope, which means that we are not expecting to see any activity or any process of mass wasting occurring on a relatively flat area. So take note, take note. And the important factor, or the main agent responsible for the movement of these weathered materials downslope, we are saying, is the force of gravity. It is the force of gravity that is acting as the main agent. So don't forget these important points. All right, back to our points. The nature and then the weight of material. The nature and then the weight of material. Now, there are um, several processes that leads to the breakdown of rocks. And for that matter, weathered materials vary in their size uh, and then the weight. Weathered materials vary, or they differ in terms of their weight and then their nature, because they may, or they are likely to undergo different weathering processes. They are likely to undergo different weathering processes. Now, the weight of the material, the weight of the material. When the material is heavy, when the weight of the material is heavy, take note, when the weight of the material is heavy, then it is likely not to move at a faster rate. It is likely not to move at a faster rate just because of the weight. Due to the weight, it is not likely to move at a faster rate compared to when the material is light, when the weathered material is light. So what are we simply saying here? The heavier the weight of the material, the lesser it is able to move, or it is able to be transported downslope. But the lighter the weathered material, then the more likely, or the more faster it is likely to be moved downslope. Let's come to the nature. Let's come to the nature of the material. The nature looks at whether the materials are compacted together, or they are somehow loosed. They are somehow loosed. Now, when the material are compacted together, then they are not likely to move at a faster rate, or they are not likely to be more wasted or moved compared to materials that are loose together. So basically, what we are saying under the nature of the material has to do with the fact that when the materials are compacted together, or they are close together, they are not able to move at a faster rate. But when the materials are loosed, when the weathered materials are loose, then they are able to move at a faster rate downslope in a particular region. So that is for the nature and then the weight of the material. I believe you are all clear. All right. Let's move on and then look at the other factor, the phenomenon of earthquake phenomenon. Who can give me the definition of an earthquake? How do you define an earthquake? How do you define an earthquake? Yes, Emmanuel. Yes, Emmanuel.
Sir,
Yes, how do you define an earthquake?
the sudden shaking of the earth from the earth crust.
All right. So Can you tell me how this phenomenon can affect or influence mass wasting? How can it determine the rate of movement of weathered material?
So okay, so when there is an earthquake or when the earth shakes, part of its components on the earth are being washed away, or some are being destroyed or being eroded away.
When the earth shakes, a part of it, a part of the landscape is being washed away or being moved. Is that what you are saying?
Yes, please.
Um, can you come again? Can you come again? Can you try and then see whether you can uh, put it in a more better way for us to understand exactly what you are trying to say?
So I'm saying when there is an earthquake, that means the earth shakes. Some of the particles on the earth surface, such as the rocks, sometimes get damaged due to maybe intense heat.
No, no, no. Do you understand mass movement or mass wasting? We are saying mass movement is the movement of weathered materials. Is the movement of weathered materials such as debris, loose gravel, any other weathered materials downslope under the influence of gravity. So here, temperature and other climatic factors has no role to play when we are talking about mass movement. Are you clear?
Okay, so then I'll come again. Yes,
All
sir.
right. All right. So who else can try? Who else can try? We are looking at the phenomenon of earthquake. How can earthquake as a factor influence or determine the rate of movement of weathered materials on a particular landscape? Yes, Matthew. Yes, Matthew. Matthew, I see your hand up. So unmute yourself and then answer the question.
Sir,
Yes.
due to the earthquake, after the destruction of the earth has been made, all the dispersed breakdown of the rocks are being taken from the top to the down, making it as a mass wasting process.
Oh, okay. Um, um, I get the idea you are trying to bring on board. All right, that is okay. Uh, that you've tried, and then that is well appreciated. All right, so a phenomenon of earthquake. Basically, an earthquake is the shaking or the trembling of the ground caused by seismic energy or waves. Now, in event of earthquake, whereby uh, we see the ground shaking, we see the ground shaking. Rocks that are located on uh, steep areas, because of the shake, are likely to what, to move, or they are likely to be what, to move from their initial location downslope as a result of what, the shaking of the ground. So it is the shaking of the ground that facilitates the movement of these uh, rocks and other weathered materials on a high slope down slope. So that is for the phenomenon of an earthquake. Now, if you have huge mass of sand on a relatively steeper slope, and then we have a phenomenon of earthquake or in event of earthquake, which leads to the shaking of that particular environment or that specific area, then there is the likelihood for those materials, those heap of or those mass of sand to be moved downslope or to be transported downslope as a result of the shaking or the trembling of the ground. So this is how earthquake as a factor can influence and determine the rate of mass movement in a particular landscape. I want you to understand the concept of mass wasting. I want you to get this concept. it is basically the movement, the transportation, the movement of weathered materials. What are weathered materials? Loose materials that can move, materials that are detached from each other. They are basically what we are referring to as the loose materials. And this phenomenon or this concept of mass wasting occurs on slope. It occurs on slopes, not on a flat area, not on a flat landscape. So this is a very important point that you need to note in this explanation on this concept of mass movement. All right, let's continue. Now, the presence of moisture or water. The presence of moisture or water. Now, who can try? Who can elaborate, or who can explain how the presence of moisture or water, perhaps in the environment or in the material, can influence or help determine the rate of weathering, the rate of mass movement in a particular landscape? Who can try? Sanyo, are you there? Yes, so we are looking at presence of moisture or water in a particular environment or in the weathered material. Pardon? Sanyo, can you come again? Peace, peace, Dansu. Peace, Dansu. Miriam, I see your hand raised. Yes, Miriam, I see your hand raised. Miriam, Pearl, I see your hand raised. Hello, Pearl. Hello, Pearl.
Flags are waving, and I think the players will be full of adrenaline going into this one.
Sir.
Yes.
Sir, please, I want to try.
All right.
Okay, so please, when there is heavy rainfall at a particular area where there is steep, where the area is steep, the weathered rock in the area can be washed away by the.
All right. Yes, you have the idea. That is good. That is okay. Pearl. Pearl. Can Pearl hear me?
Now they've got a chance in this part of the pitch. That's easy for the goalkeeper.
Sir,
Yes.
sir, like during the rainy season, when there is like a flood all over, the water carries away the weathered materials. down down slopes. Yeah, so that's
Oh,
what I think.
oh, okay. All right. So that is equally correct. Yeah. So to add to what your colleagues have said, um, when we are looking at the presence of moisture or the presence of water, um, if you are there and then your television is on and then they are playing football in your room, mute yourself so that it does not interfere with the class. Once again, if if you are in a room where there is a television on, you have your television on, and then they are playing football. They are playing football on the television. Uh, the sound of that environment is interfering with the lesson. So kindly mute yourself. If the person is listening, the person should quickly do that now. All right, let's continue. The presence of moisture or water, like your colleague said earlier, in events of rainfall or precipitation, when we have a precipitation phenomenon on a landscape that is relatively steep, then the water or the rainfall will now have the potential to move, to transport these weathered materials on the landscape downslope, downslope, as it occurs in what? In erosion. You see, in events of erosion, materials are able to be carried or moved from their location to another location. So basically, this is what happens on a steep slope in event of rainfall or any other precipitation phenomenon, whereby the materials are moved or the materials are carried downslope. Now, the other aspect of this point has to do with the water content in the material, the amount of water content in the weathered material. If the water content in the weathered material is high, if the amount of water or the water content in the weathered material is high, then we expect this weathered material to move at a faster rate because of the water content. Due to the water content, we expect this weathered material to move at a faster rate. Now, when there are no water element, or when the water content is very low, then we also expect this weathered material to move at a relatively slower rate. We are expecting this weathered material to move at a relatively slower rate compared to materials that have high water content. Are we clear? All right. Now, having looked at the factors that affect mass wasting or mass movement, we can proceed to look at some of the various types of mass movement. Let's proceed and then look at some of the various types of mass movement or mass wasting. All right. Now, in arriving at these various types of mass wasting, we use or we depend highly on the rate of movement. The rate of movement. That is how fast the material, the weathered materials are able to move downslope under the influence of gravity. How fast this material are able to move helps us to determine these various types of mass wasting. So take note. Like I said, based on the speed of movement, based on the speed of movement of weathered materials, that is how fast the materials are able to move. Mass wasting can be categorized under the following types. So we shall look at the various types of mass wasting or mass movement. All right. The first one we are looking at is the rockfall. We'll look at rockfall. I'll look at landslide, rock slide or slumps. We'll also look at soil flow, earth flow or mud flow, what we basically refer to as solifluction. And finally, we shall look at soil creep. Soil creep. These are the various types of mass wasting or mass movement that we shall look at. Now we'll take them one after the other, look at how they occur or how they happen, and then we'll proceed and then look at some of the possible effects of mass wasting. All right, let's take the first one, rock fall. But then, how do you explain rockfall as a type of mass wasting or mass movement? Who can try? Who can explain rockfall as a type of mass movement or mass wasting? Students who will try, I ask you guys to go and read on this before you come for the class. All right, let's look at the rockfall. The rockfall as a type of mass movement or mass wasting. All right. Now, the rockfall basically refers to the sudden falling or dropping of rocks or rock debris. Now, how does it occur? This usually occurs when large boulders of rock or debris fall from a steep slope or a cliff of an appreciable great height or elevation. When it occurs or it happens that rocks of a large size suddenly falls from a steep slope or a cliff downslope, then we have the phenomenon of what? Rockfall. And this is what we are referring to as the rockfall. Now, when the fall continues, if you have the phenomenon or the situation whereby rocks continue to fall from a particular spot and then they fall and then they find themselves at a particular location over and over again. Once this process continues, the rocks as they fall will continue to break further. They will continue to break further. So once they are broken further, once these materials as they fall undergo further disintegration, then they accumulate at the base. They accumulate at the base of the cliff where they fall to form what you call a talus. So you can see in your objectives or any other examination whereby they will ask you to explain talus. They will ask you to explain talus. So you should be able to do this. Let me also be quick to say that in arriving at the various types of mass movement, we said the basic or the most the key criteria we use in arriving at the various types of mass movement has to do with the speed of movement, how fast these weathered materials or the materials are able to move downslope. It is based on this factor that we are able to arrive at these various types of mass movement or mass wasting. Now, when you take the rockfall, among the other types of mass movement, the rockfall is the most sudden and it is the most fastest type of mass movement among the various types of mass movement that we have. So take note. Take note of this point. Very, very important. The rockfall is the most sudden and then the most fastest type of mass movement among the various types of mass movement. So we are saying this occurs when rocks suddenly fall from a steep, a high steep, or fall from a cliff of great elevation, and then finally accumulating at the base. And when the fall continues over a long period of time, when the fall continues for a long period of time, then the materials begin to accumulate at the base of the cliff where the rocks eventually land. And once they accumulate, they undergo further disintegration or they undergo further breakdown to form what we call a talus. To form what we call a talus. All right. So that is basically for the rockfall. And I did indicate that among the various types of mass movement, rockfall is the most sudden or the fastest among the various types. That is in terms of how fast the materials are able to move. If you look at the activity or the phenomenon involving rockfall, the materials move at a faster rate. They move at a faster rate compared to the other types of mass movement. So take note. All right. Let's move ahead to look at the second type of mass movement. So like I said, rockfall is the most rapid among the various types of mass movement. So this is a very important point you need to note. So let's watch our screens. This is just an image showing boulders of rocks suddenly falling from a high elevation or a cliff and then landing at the base here. So if you can see your mouse pointer, this is a large boulder of rock. This also this is quite smaller relatively compared to the initial one. And then you can see other smaller materials or other smaller rocks in terms of their sizes falling and then landing at the base here. This material, these boulders were, or they originated from the top of the cliff. As you can see, they originated from the top of the cliff. And here, this portion of the rock being broken, it is likely that once the rock fell from the steep and then landed here, then the impact was so great that that part of the rock will have to be broken off. That is how come you see that portion as if it has been disintegrated. All right. Now, when these materials, the materials that accumulate at the base here, this is what we refer to as the talus. So once this process continues, the rocks are falling on each other continuously. Then the materials at the base there are likely to undergo further disintegration and they eventually accumulate at the base to form what we call the talus. What we call the talus. So this is basically about the rockfall. This is basically what we are referring to as the rockfall. I believe you are all clear. All right. Let's look at the other type of mass movement. let's look at the other type of mass movement or mass wasting. We are looking at the landslides, the rock slides, or the slabs. All these three terms are referring to the same thing. The landslides, the rock slides, or the slums are referring to the same concept. All right. Now, this is a relatively slower movement. This is a relatively slower movement of debris or loose materials by sliding or slipping. So in terms of the rate of movement, how fast these materials are able to move, this is a relatively slower movement compared to what we saw during event of rockfall, or when rockfall develops, the materials tend to move at a faster rate compared to what happens under landslide. So this is a relatively slower movement of debris or loose materials by sliding or slipping. Now, it usually results, this process or this type of mass movement usually result in the movement of large mass of rocks. When large mass of rocks tends to move over each other, when you have large mass of rocks or large mass of weathered materials mass at a particular area, and they tend to move over each other, then this will give rise to the landslide. Now, the movement as these materials move downslope, the movement is in succession. The movement of these weathered materials downslope is in succession, giving rise to a step-like feature. So you are likely to see a step-like feature after the event or after the phenomenon of a landslide has taken place. Now, earthquakes also play a crucial role in making it possible for this phenomenon to occur. So if in event of earthquakes or during volcanic eruptions, it is possible to have certain portions of the land or the landscape sliding over each other. All right, how do they occur? Let me show you an image here. All right, so you can see the slope here. This, look at the mouse pointer. This is a slope, and this, of course, a steep slope. Then this is also a slope. Suddenly, this portion of the land is the first to initiate the sliding. So the first portion of the land initiated the sliding, followed by the other succession. Then we have the final succession here. So when this occurs, initially, these materials here were part of the, as you can see the mouse pointer, look at the mouse pointer carefully. These materials, as they are moved here, initially were here. They were part of this landscape. So as a result of perhaps it can be an earthquake or during volcanic eruptions, these materials or this portion of the landscape is likely to move in a succession manner or to move in a successive manner, giving rise to the step-like feature we are referring to as a landslide. So landslide basically shows a step-like feature. Landslides usually shows a step-like feature. So you need to note this important description or this important point. All right. We also refer to them as slumps or slumping. Slumps. So you are likely to see slumps, landslide, rock slides, and then other related terms. All right. Now, the soil flow. Let's look at the third type of mass movement. The third type of mass movement or mass wasting. The soil flow or the earth flow or the mud flow. Okay. Now, in terms of the speed of movement, in terms of the speed of movement of these weathered materials under this type of mass movement, the speed of movement is relatively rapid. The speed of movement is relatively rapid compared to the landslide. So take note, compared to the landslide, the speed of movement of this weathered material is relatively rapid or more faster compared to that of the landslide. All right. How does it occur? Or what gives rise to soil flow or air flow or the mud flow? We are saying this occurs when fine grained materials or rock fragments become saturated with water and therefore move or flow down a gentle slope under the influence of the force of gravity. Under the influence of the force of gravity. Now, the speed or the velocity of the flow, that is how fast these materials are able to flow or move down slope, varies. It varies. And it also depends on the amount of water contained in the material, the amount of water contained in the material or the saturation. Now, basically, what are we saying? The more or the higher the water content, the more or the faster the materials are able to flow or move down slope. The more or the higher the water content, the higher or the more faster the materials are able to move or flow down slope, and then vice versa. In other words, we are saying the higher the water content, the higher the velocity or the speed of the flow. The slower or the lower the water content, the less or the slower the velocity of the flow or the speed of the flow of the weathered materials. This is basically what we are talking about or we are referring to. Now, when we're looking at the factors that affect weathering, when we're looking at the factors that affect weathering, we mentioned the presence of moisture or water. We mentioned the presence of moisture or water, where we said that the amount of water content in the material can determine how fast this material will be able to move downslope under the influence of gravity. So here, we are saying this occurs when weathered materials become saturated with water. When water mixes with weathered materials, then the water content or the presence of water tends to cause these materials to flow or to move downslope. And this is what we are referring to as the soil flow, the air flow, or the mud flow. The popular name known for this type of mass wasting is the mud flow. Mud flow. All right. We also said the speed or the velocity of the flow or of the movement varies, and this depends on the amount of water content. So if the water content is very high, then the velocity or the speed of the movement is likely to be high. And when the water content is very low, then we are expected to have the speed or the velocity of the movement also becoming very low. So take note. Do you have any questions? Are you clear? Yes, Pearl. Your hand is raised. Pearl.
Say,
Yes.
say, like can we say that the rock fall and
Yes.
the soil fall or the earth fall, like if they ask us to give the difference? Can we say that the rock fall is more more rapid than the soil fall? Because you said earlier that the soil fall they are relatively rapid, and pertaining to the rock falls, you also said that it's rapid. So if they ask us to give the difference, please can you help me with that?
Oh, all right. One thing that you need to note regarding the rockfall and then the soil flow. Under the rockfall, the process or the mechanism leading to the fall are quite sudden. They are quite sudden. Okay, when we say something happens suddenly, I believe you understand. All of a sudden, you have a portion of the rock detaching from the parent rock and then falling eventually. So that is the rockfall. Now, for the soil flow to occur, first of all, we expecting water, or we expect that the material becomes saturated with water. And once the material becomes saturated with water, and then the amount of water is also very crucial. So if the material becomes saturated with water, then this will cause the material to what? To flow due to what? The presence of water, due to the water content. It will cause the material to flow. So you can just imagine it. You have a mud flowing. That is what we are referring to. So yes, in terms of the speed, the rockfall, yes, even though the rockfall is rapid, that is, it is very fast compared to all the other types of mass wasting. This type of mass wasting, the soil flow, the earth flow, or the mud flow, is also rapid. Relatively, it's also rapid. What I mean by relatively rapid here has to do with the fact that in terms of the rate of flow, or the speed or the velocity of flow, it is faster than a few other types of mass wasting, like the landslide and then the soil creep, So, and then let me also be quick to add, the rockfall happens on a more steeper slope or a cliff. The rockfall happens on a steeper slope or a cliff. Now, the soil flow happens on a gentle slope. This happens on a more gentle slope, or a relatively gentle slope compared to that of the rockfall. Are you clear now? Pearl, are you okay?
Yes, sir. Please, thank you.
All right. Now, the rest of the class, are you okay with the explanation of the various types of mass movement? We've looked at the rockfall, we have looked at the land slide, and then we are now looking at the soil flow, or the earth flow, or the mud flow. Now, let me ask a question. Here before we proceed. What is the most important or the unique agent that facilitates the movement of these weathered materials downslope? Students, can you hear me? Students, can you hear me? All right, so let's look at the soil flow or the mud flow. Let's look at the mud flow. Now, the image we have here, look at your mouse pointer carefully. Look at the mouse pointer carefully on your screens. We can see the description of the soil flow or the mud flow as we are explaining. Now, these materials were transported or they were moved from an initial location and then they are being moved to this location. You can see the water content or the amount of water contained in this material acting as um, uh, um, aiding the movement of this material to be able to move downslope. So the presence of the water or the amount of water contained in this material is responsible for the movement of this material from their initial location to this current location. So that is basically about the mud flow. This is basically about the mud flow. You can see the role of water, and then most importantly, the role of the force of what? Gravity. The role of the force of gravity is also very, very important. All right. Now the final type of mass wasting we are going to consider for today is soil creep. Soil creep. Soil creep. Okay. So soil creep. So we'll look at a brief description of soil creep, and then we'll end the lesson here. Now, let me add this quickly. Among the various types of mass movement that we have looked at, the 4 types of mass movement, the soil creep is the slowest among the various types in terms of the speed or the velocity of the movement of the weathered materials downslope. The soil creep phenomenon or the soil creep type of mass movement is the slowest compared to all the other types. So take note of this before we continue. What is a soil creep? Basically, it is the slow downward movement. That is why the slow is there. This is a slow downward movement of soil down a gentle slope under the influence of the force of gravity. Soil creep basically refers to the slow downward movement of the soil down a gentle slope under the influence of gravity. Now, there are occasions where water may act as a lubricant. There are few occasions where water may act as a lubricant to facilitate the creeping of the soil. Now, soil creep among the various types of mass wasting, soil creep can hardly or barely be noticed. It will be very difficult for persons or individuals to even realize that this type of mass wasting or this phenomenon is taking place in a particular landscape. Usually, with the aid of objects that are erected on the soil or on the landscape, when these objects tends to move in a direction or shift in a direction of the flow of the soil, then it is possible to notice the effect or the phenomenon of a soil creep taking place in a particular landscape. So take note of this. It is by far the slowest type of mass movement. Water may sometimes act as or facilitate the creeping by acting as a lubricant. Then we are also saying that this type of mass wasting can hardly or barely be noticed or even recognized in a particular landscape. It is not it is not easily detected in an environment once this is happening or this is taking place. But with the aid of objects such as fences or a fence, a tree, or any other object that are erected or that are placed on the landscape, once this material tends to move or shift in the direction of the flow or in the direction of the movement of the soil, then it is possible for persons or individuals to notice the activity or the phenomenon of soil creep taking place in that particular environment or landscape. So take note. Now let me give you this image. So you have to take note. Like I said, soil creep is the slowest among the various types of mass movement. And sometimes it may take years before it can be noticed. It may take several years before even individuals can notice that this type of mass movement or this phenomenon is taking place in a particular environment or landscape. Now, don't forget the important role played by the force of gravity. So the force of gravity plays an important role here. Now, uh, by far, we are saying this is the slowest movement. It is the slowest movement. It can barely be noticed. The rate of movement cannot even be determined. You can't determine how fast these materials are able to move down slope. And it may take several years. It may take several years before it can be detected or it can be determined that this phenomenon or this activity has taken place in a particular environment. Now, we look at the second image here. You can see this fence and then the poles as well, you know, having some or bending towards a particular direction, bending towards a particular direction. Initially, uh, this were not how they were erected, or this were not how they were placed on the landscape. But as a result of the effect, as a result of the effect of the soil creep, the soil creeping, we happen to see this the fence moving or shifting in the direction of the creeping or in the direction of the creep. So this is how soil creep occur. Most of you may have noticed this in your environment, in your community, but you don't actually know what exactly uh, that is happening or what exactly has happened. So once you walk across your environment or your community and you see this kind of development, we refer to them as what? Soil creep. Now, we'll end a lesson here. If you have any questions, you guys can ask before we end the class. Our time is fast spent. Yes, I see two hands raised. Um, all right, yes, I see two hands raised up. So ask the question and then let's uh, end the class. Unmute yourself and then ask the question. Students, do you have any question? If you have any question, ask. All right. So if you don't have any question, we'll bring the lesson to an end. And the next time we'll meet, we shall continue and then look at the effects of mass wasting, the effects of mass wasting or mass movement. I'll make the slide or the notes available on our Google Classroom platform so that you guys can go there and have access to these notes. All right. So we'll end the class here.